Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today, inshallah, we will start in acids, bases, and salts. Acids, bases, and salts is very important topic in IGCSE syllabus. We can say that it is introduction for as-level students in their acids and bases and salt study. Today, at first, we want to know where we can find acids. Acids, we can find it everywhere in our daily life. You can find acids in orange, you can find it in lemon, you can find it in grapefruit, we can find it in our daily life everywhere. Acids are also in detergents, we can find it inside our labs. We have very strong acids. We have mineral acids, hydrochloric acid, sulfuric acid, and so. Bases are compounds which we can find it in detergents, we can find it in soups, we can find it in chemicals inside our lab. So we can find bases like sodium hydroxide, potassium hydroxide, magnesium oxide. All of these are compounds known as bases in our labs. And of course we have different concentration of hydrogen, proton, and hydroxide ion. We will know what is the meaning of hydrogen, proton, hydroxide ion right now. And at last we have salts. Salts are compounds. Of course we can find it everywhere. At least we can find it in our kitchen. We have sodium chloride salt in large quantity in all of us kitchens. And we have mix of acids and bases everywhere. So we want to start. What's the meaning of acid? What's the meaning of base? What is the use of acid? What is the use of base? Of course, acids and bases, we can find it in stings, in ant stings and different types of stings. We want to know what is the meaning of stings treatment, how we can treat different types of stings. Now we will know what's the meaning of acids and what's the meaning of bases. At first, we want to know what is the meaning of indicators. Indicators are substances extracted from plants and its color change depends on the pH of solution. pH of solution indicates the concentration of hydrogen ion or the concentration of hydroxide ion inside your solution. At first, we have pH scale. pH scale is used for knowing the concentration of hydrogen ion or the concentration of hydroxide ion, or we have neutral solution with equal concentration of hydrogen ion and equal concentration of hydroxide ion. First type of indicator is universal indicator. By using the universal indicator, we have strong acids. Strong acids, its pH from 0 up to 2. Its color ranges from red up to orange color. We have weak acid. Its color ranges from the orange up to yellow color. We have very weak acids and we have neutral solution. Neutral solution pH is 7, exactly 7. We have weak bases. Weak bases, its pH ranges from 8 up to 10. So we are talking about blue color. And we have strong base. Strong base color is violet or purple color. It is the first type of indicators which we can find that inside our lab is universal indicator. Universal indicator is used for indicating the pH of the solution depends on the color of the solution by adding only 1 drop or 2 drops of the indicator. Second type of indicator, it is very important type of indicator. We usually are using it in making a titration reaction. Universal indicator is the first type and phenolphthalein is the second type. Phenolphthalein color in acidic and neutral solution is colorless and its color in basic solution is pink color. Of course, we can differentiate between colorless solution and pink colored solution. So we like to use phenolphthalein in making titration inside our lab. We have another type of indicator. We have methyl orange. Methyl orange, its color in neutral solution is orange. Its color in acidic solution is red color. And its color in basic solution, of course, is yellow color. So its color in alkaline medium is yellow color. So we like to use methyl orange too in differentiation between the acidic and basic medium. We are talking about the conversion of color from red color into the yellow color. And of course we have pH meter. pH meter is very accurate method for determining the pH of your solution. Of course we will have the reading indicates the pH of your solution in 2 decimal numbers. So we are talking about very accurate method for knowing the pH of our solution. At last we have litmus paper. Litmus paper color in neutral solution is purple color, and its color in blue solution is blue color, and its color in acidic solution is red color. So we are talking about different types of indicators. Indicators are substance extracted from plants, and its color changes depends on the pH of our solution. The first and very important type of indicators is universal indicator. Its color in strong acid is red, its color in weak acid is yellow, its color in neutral solution is green, and its color in weak base is blue, its color in strong base is violet or purple. We have very important type of indicator, phenolphthalein. Its color in acidic and neutral solution is colorless, and in basic solution its color is pink or purple color. We have methyl orange. Its color in neutral solution is orange, its color in acidic medium is red, and in basic medium is yellow. We have pH meter. We have pH meter for the soil also. We can know the pH of our soil by using pH meter. And of course we have litmus paper. We studied it before many times. Now we want to know what is the meaning of acid. Acid, we can find it in different compounds in our daily life. We can find it in lemon, we can find it in orange, we can find it in grapefruit, we can find it in vinegar, we can find it in spoiled milk. All of these compounds are sour taste compounds. We have specific taste for these compounds. All of these compounds are known as acidic. Acidic compounds can dissolve in water. Take care, it must dissolve in water. Acids are not working in organic solvents, so it must dissolve in water to produce hydrogen proton. Hydrogen proton, we want to know what's the meaning of hydrogen proton. Hydrogen proton, we have neutral hydrogen atom. We studied before hydrogen atom is H1, 1. Inside hydrogen atom we have only one hydrogen proton. We have only one proton inside the nucleus. And we have one electron, only one electron around the nucleus. When hydrogen is involved in the chemical reaction, hydrogen usually loses its electron and converted into ion without electrons, ion with only one proton inside the nucleus. So we can say we have hydrogen proton. We have hydrogen atom free of electrons. We have hydrogen atom just with one nucleus, just with proton inside the nucleus. We can see the same in water molecule. In water molecule we have oxygen atom attached to two hydrogen atoms. So we have covalent bond between oxygen and hydrogen atoms. Oxygen atom has high electronegativity. Electronegativity means high ability for the oxygen atom to attract electrons. So it will take the electron from the hydrogen atom. And we will have hydrogen atom without electrons. Hydrogen atom with only one proton inside the nucleus. So we have hydrogen proton and hydroxide ion, and we have OH group with one electron, with one excess electron. So we have hydroxide ion. In water, we have equal concentration of hydrogen proton and hydroxide ion. As we have equal concentration of hydrogen proton and hydroxide ion, we have equal concentration of acidic and alkaline properties. So we have neutral solution. In water, pH is 7. In water, the color of universal indicator is green color. We have green color of the universal indicator. When we start to dissolve acid in water, the concentration of hydrogen proton will increase. We will have excess of proton as acids are proton donor. Acid can donate hydrogen proton. So we will have excess of hydrogen ion concentration, and the color of our litmus paper will turn into blue, and pH will be acidic, so it will be less than 7. So we can see in hydrochloric acid HCl, we have covalent bond between hydrogen and chlorine. Chlorine has high electronegativity, so it will attract the hydrogen electron, and we will have hydrogen free of electrons. We will have hydrogen proton and chlorine Cl negative. The same in nitric acid HNO3, we will have hydrogen proton and nitrate group in O3 negative. In the case of sulfuric acid, we have 2 hydrogen protons and 1 sulfate group SO4 minus 2. Take care, in the case of sulfuric acid, we have dibasic acid. We have acid contains 2 hydrogen protons. We have acid can donate 2 hydrogen protons, so we can see it in sulfuric acid. In phosphoric acid, we have 3 hydrogen protons and 1 phosphate group. In acetate or acetic acid, we can have 1 hydrogen proton and acetate group CH3COO negative. So we are talking about acids. Acids can donate hydrogen proton. Acid can dissolve in water and increase the concentration of hydrogen proton. By increasing the concentration of hydrogen proton, so our balance will be unequal. We will have excess concentration of hydrogen proton. So we will have acidic solution. So we will have solution colored if we have high concentration of hydrogen proton with red or orange color. If we have weak concentration, we will have yellow color. So we are identifying acids. We must memorize how to write the mineral acids structure, how we can write hydrochloric acid, how we can write nitric acid HNO3, sulfuric acid H2SO4, phosphoric acid H3PO4, and at last organic acids like acetic acid. Acetic acid is one of weak acids which can dissolve in water, and we will remove the external hydrogen proton, and we will have acetate ion CH3COO negative. So it is the meaning of acids. We will transfer to bases. Bases are in opposite to acids. Bases, we have large general group is known as bases. Bases are metal oxides like copper oxide, magnesium oxide, calcium oxide, sodium hydroxide, potassium hydroxide, copper hydroxide. All of these are bases. Bases as general can react with acids in neutralization reaction to form salt and water. But in our large group of bases, we have a small group of alkalis. Alkalis are bases dissolved in water. They can dissolve well in water, like sodium hydroxide and potassium hydroxide. So we have alkalis. Alkalis are bases dissolved in water to give hydroxide ion. Our pH of the solution is more than 7. We have excess of hydroxide ion concentration, like sodium hydroxide dissolved in water to give sodium ion Na positive plus hydroxide ion OH negative, potassium hydroxide K positive plus OH negative. Ammonia solution is one of weak bases. Ammonia solution dissolved in water to give ammonium ion NH4 positive and hydroxide ion. So we have excess, we have high concentration of hydroxide ions, and they will increase the concentration of hydroxide ions, they will increase our pH, and our balance will be unequal. So the color of the indicator will be blue or purple color. Take care, alkalis is proton acceptor. Alkalis can accept a hydrogen proton. So if we have chemical reaction between water and hydrochloric acid, we will have hydronium ion H3O positive plus chlorine ion. You can be asked inside the exam to tell which one is acid, which one is base, and identify what's the meaning of acid and what's the meaning of base. In this question, you must know that acid is proton donor. Acid can lose protons, and base are proton acceptor. Bases can accept protons. So we have water. Water will accept hydrogen proton and convert it into H3 instead of H2. So we have increase in hydrogen proton concentration. So water is proton acceptor. Water, of course, is alkali. It accepts the proton. And we have hydrochloric acid converted into Cl negative. HCl lose hydrogen proton. So, of course, we are talking about hydrochloric acid is acid. It can lose its hydrogen proton. So, it is proton donor. So you must know exactly that acids are proton donor and bases are proton acceptor. You must know how to write the equation and how to extract the acid and the base from your equation. Now we will start to transfer into comparison between strong acid and weak acid, strong base and weak base, strong alkali and weak alkali. At first, strong acids are completely ionized in water. Strong acid will dissolve it in water to give very high concentration of hydrogen proton. Like hydrochloric acid, completely ionize it into hydrogen proton and chlorine. So we have monobasic, we have monoprotic acid. We have acid can lose only one hydrogen proton. Nitric acid HNO3 can be converted into hydrogen proton and nitrate group. It is also monobasic monoprotic acid. Sulfuric acid can donate to hydrogen proton. It is dibasic diprotic acid. Phosphoric acid H3PO4 can give 3 hydrogen protons and phosphate group. So we have tribasic, we have triprotic acid. So we have acids are completely ionized in water. All of these reactions are one direction reaction. Just by adding hydrochloric acid, it will be directly converted into hydrogen proton and chlorine. All the molecules of hydrochloric acid will convert it into hydrogen proton and chlorine. So we are talking about strong acids. Weak acids, they are partially ionized in water. For example, if I add 100 molecules of acetic acid, 100 molecules of methanoic acid, only one molecule or less than one molecule will be converted into hydrogen proton, it is hydrogen proton, and will be converted into a state group. It is hydrogen proton. The same in carbonic acid. Carbonic acid is weak acid. It is partially ionized. So we can say carbonic acid is weak acid. It's directly converted into water and carbon dioxide. Okay. Strong acids, we have high concentration of hydrogen proton. We say if we add 100 molecules of hydrochloric acid, will be converted into 100 molecules of hydrogen proton and 100 molecules of chlorine. In the case of weak acids, we have low concentration of hydrogen proton. We say if we start with 100 molecules or more of methanoic acid, only one molecule will be converted into hydrogen proton H positive and acetate group. In the case of strong acids, we have low pH. We have pH from 0 up to 2. Take care, as the pH decreases, the acidity will increase. In the case of weak acids, we have high pH. It's pH from 2 up to 4 and more. Color of universal indicator is red. Color of universal indicator is yellow. It's very good conductor of electricity. Take care, conducting electricity is related to having free ions. Free ions can move and conduct electricity. In the case of strong acids, of course, we have high concentration of free hydrogen protons and high concentration of free chlorine ions. So they are free, they can move, they can conduct electricity very well. But in the case of weak acids, we have very low concentration of free ions. How they can move, how they can conduct electricity. So we are comparing between good conductor of electricity and bad conductor of electricity. Strong acids like mineral acids, like hydrochloric acid, sulfuric acid, and nitric acid. They are mineral strong acids. Weak acids like organic acids, methanoic acid, citric acid, vinegar, carbonic acid, all of these are weak acids. Now we will start to compare between the strong alkali and weak alkali. They are exactly the same but with different examples. Strong alkali completely ionized in water. If we add sodium hydroxide, potassium hydroxide, they are alkali. They are completely dissolved in water. So all of your molecules will convert it into sodium ion and hydroxide ion. So of course the concentration of hydroxide ion will increase. But in the case of weak alkali, they are partially ionized in water. We have small number of molecules will be ionized in water. If we react ammonia in H3 plus water, it will convert in H4 positive plus hydroxide ion. In the case of a strong alkali, we have high concentration. Of hydroxide ion. Our pH ranging from 12 up to 14. But in the case of weak alkali, low concentration of hydroxide ion, your pH is less than 12. Its color of universal indicator is purple or violet. Color of universal indicator is blue. Our examples, of course, are alkalis like sodium hydroxide, like potassium hydroxide, and our weak alkali, of course, we have ammonia solution. It is a very strong weak alkali. You must memorize how you can differentiate between strong acid and weak acid, at least if you have any question about comparison between strong acid and weak acid, or why phosphoric acid is weak acid than sulfuric acid. You must know the points of differentiation. At least you will have 3 marks for this question inside the exam. Now we will start to know the different types of oxides. We have four main different types of oxides. We have the acidic oxides, basic oxides, we have neutral oxides, and we have the amphoteric oxides. Now, acidic oxides are non-metal oxides. Non-metal oxides are acids. Basic oxides are metal oxides, they are bases. We have neutral oxides, we have oxides that can't react with acid, can't react with base. They are neutral compounds like water, like carbon monoxide, nitrogen monoxide. And at last we have amphoteric oxides, they can react with acid, they can react with base, and they can form salt and water with all of them, like zinc oxide, like lead oxide, like aluminium oxide. Now we will start with acidic oxides. Acidic oxides like carbon dioxide, sulfur dioxide, nitrogen dioxide, and nitrogen monoxide. They can react with alkali to form salt and water. Acidic oxides are non-metal oxides. They are acids. They can react with alkali to form salt and water. Basic oxides like sodium oxide, calcium oxide, potassium oxide, magnesium oxide, copper oxide, all of these are metal oxides. They can react with acids to form salt and water. Amphoteric oxides like zinc oxides, like aluminium oxides, like lead oxides, they are oxides can react with acids and can react with alkalis to form salt and water. At last, we have neutral oxides like water, carbon monoxide, nitrogen monoxide. They don't react with acid, they don't react with base, just they are neutral, don't react with acids or bases. Now we will start in different types of acids and bases and their reaction. We have different types of reaction. These types of reaction, you must know them. You must try to practice how to write the chemical equation at home. At first, the first type of reaction, we have metal plus acid to form salt and hydrogen gas. Take care the elements are arranged according to their reactivity: potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. At first, you must know in this reaction it is unsafe to add very reactive elements like sodium or potassium, because their reaction inside the lab is very vigorous reaction. It is unsafe reaction. So we can use this reaction for react the medium elements in reactivity or moderate elements in reactivity like zinc, iron, tin, lead, carbon, aluminium, magnesium at most. And the elements which are less reactive than hydrogen like copper, silver, gold, platinum, they are elements, they are not reactive. You will study it later. They are unreactive elements. They are less reactive than the hydrogen, so they can't fire the hydrogen from acids. They can't fire the hydrogen and take its place. So we are talking about elements are very unreactive. According to we having very unreactive elements, we can see in the first reaction zinc plus hydrochloric acid will form zinc chloride plus hydrogen gas. Zinc is one of moderate reactive elements. Iron plus nitric acid will form iron nitrate plus or ferric nitrate plus hydrogen gas. We have metal nitrate. So if we want to form nitrate, we will react our metal with nitric acid. If we want to form chloride, we will react our metal with hydrochloric acid. If we want to form metal sulfate, we will react our metal with sulfuric acid. Lead plus sulfuric acid will form lead sulfate plus hydrogen gas. We can detect hydrogen gas inside our lab by pop sound with lightning splint. You can try to do the experiment inside your lab. It is the first type of reaction between metal and acid to form salt and hydrogen gas. We are talking about the reaction of the moderate reactive elements. We can't use the highly reactive elements, they are unsafe. We can't use the low reactive elements because they are unable to fire hydrogen and take its place. The second type of reaction between metal oxide and acid. Metal hydroxide and acid. Metal oxide and acid and metal hydroxide and acid, they will form salt and water. Like reaction between sodium hydroxide and hydrochloric acid, it will form sodium chloride. Just we have couples will change their place. Sodium will take chlorine and hydrogen will take water. So we will have sodium chloride plus water. Copper oxide plus sulfuric acid, it will form copper sulfate plus water. So we are talking about just change the position. And in the case of the first reaction, zinc is more reactive than hydrogen. So zinc will fire the hydrogen and will take its place. And we will have zinc chloride plus hydrogen gas. In the case of carbonate plus acid, we will have salt plus water plus carbon dioxide. Like calcium carbonate plus hydrochloric acid change the position, we will have calcium chloride plus H2CO3 carbonic acid. Carbonic acid is weak acid, it will convert it into water plus carbon dioxide. Calcium carbonate plus nitric acid, we will have calcium nitrate plus water plus carbon dioxide. Carbon dioxide can turn lime water into cloudy. It can turn it into milky or turbid solution. We can see it in our picture. Calcium hydroxide, in the lime water, we have calcium hydroxide. Calcium hydroxide is clear solution. By adding carbon dioxide, it will form calcium carbonate, CaCO3 plus water. So we are talking about different types of reaction, different types of acid and base reaction. We can say they are types of neutralization reaction. You must know all of these different types of reaction. You must practice how to write the equation between metal and acid, between metal oxide and acid, between metal carbonate and acid. In your home, you can start to write the equation between iron and hydrochloric acid, iron and nitric acid, iron and sulfuric acid, zinc and hydrochloric acid, zinc and nitric acid, zinc and sulfuric acid, and so you can try the equation between copper and hydrochloric acid and start to write. We have no reaction, they are low reactive elements. Metal oxide and acid, just write any metal oxide, write copper oxide plus hydrochloric acid, copper oxide plus nitric acid, copper oxide plus sulfuric acid, ferric oxide plus hydrochloric acid, ferrous oxide, and so metal hydroxides, different metal hydroxides, like for example zinc hydroxides, lead hydroxides. They are different types of hydroxides, and try to write the equation with your hand. Try to practice it many times. Equation, you need to practice it. You need to be clever and smart in writing chemical equation. Just we will change the position. Take care the metal must be at first in your compound and the non-metal must be the second part in your compound. At last, we will finish with the use of acids and bases in our daily life. At first, acids, we can use it daily. Of course, if you eat a lot of proteins, if you eat a lot at your home, you start to feel with hyperacidity. Hyperacidity inside our stomach, usually we have excess of hydrochloric acid. Hydrochloric acid is responsible for protein digestion. And when you start to eat a lot, you will have excess of hydrochloric acid. It will start to move out of your stomach and will start to move inside the esophagus. And you will start to feel with burning sensation. This burning sensation is related to excess of hydrochloric acid inside your stomach. Exactly, we can relieve the burning sensation by using antacids. Antacids are compounds inside your pharmacy. You can find it. Of course, in antacids, we just have basic compounds like magnesium carbonate, magnesium hydroxides. We are adding weak bases, not very strong alkali, because we need to just neutralize the excess of acid. We have these compounds, we have bases like magnesium carbonate, calcium carbonate. We have these compounds are mixed with vitamin C. They can be mixed also with something for relieving the burning sensation till the activity of neutralization reaction is finished inside your stomach, and you will have the relief sensation within minutes. So we are talking about antacids. And we can use the weak acids for cleaning kettles. Kettles, if you are living in an area in which we have excess of salts, in which we have excess of limestone salts, for example, limestones are calcium carbonates. They will be started to be decomposed in your compound. They will start to precipitate it in your kettle and it can damage it. If you want to clean it, of course, we need to use weak acids. We won't use very strong acids like hydrochloric acid because it can eat the metal. It can damage your metal. Hydrochloric acid can react with iron, so it will damage it. We will just start to add weak acids like vinegar, like citric acid, like lemon juice. All of these are weak acids. They can react with calcium carbonate salts and dissolve it directly. And of course, we can treat soil and treat waste water by adding the calcium carbonate, by adding limestone. By adding limestone or by adding calcium carbonate to the soil, we can convert acidic soil into basic soil. We can increase the pH of your soil. But if you want to decrease the pH, we will start to add ammonia fertilizers. Okay. Now we can see that we have finished our topic today about acids and bases, and we will start to speak later about preparation of salts inside the lab. You must know how you can write the chemical equation. You must practice it. You must know the ideal identification of acids and ideal identification of base. I hope that you enjoy our video today. Don't forget to give us like and share with your friends, and don't forget to make subscribe and reactivate the bell to have any new video. Thanks for your watching. See you later. Assalamu alaikum wa rahmatullahi wa barakatuh.